Homework ones. Let's look at section 3.4, and I do want to talk about 37 through 39 a little bit, and I do want to talk about 21, that one. So we'll do those. So other than those, other than 21, 37 through 39, somebody have one of those they want to, that's right, yeah. 23. Okay, x squared times, okay, good. So, x squared times arctan. Now I would always write that x to the 1/2 right away, right? When I see square root of x, I'm going to write down x to the 1/2. Okay, so, and does everybody have the derivative rule sheet? I posted it online, I can't remember if everybody shared it. All right, so this is first going to start off, to get the derivative, start off by using what? What rule? What rule? Product rule, right? Right away, this is a product rule. Now, yeah, it's got some stuff on the inside, but we'll deal with that when it's time to deal with that. So we got u prime v plus uv prime, right? So we do u prime, which would be 2x. We do v, which is just leave this alone. We do plus u, which is x squared. Now, we worry about that thing on the inside, right? And so I don't think I'm going to need parentheses because I don't think there's going to be any plus signs or anything in there, but I'll put a big set of parentheses just so we understand that what I'm about to do is that piece right there, okay? Sometimes that can get tricky when that last piece is kind of has a bunch of stuff on it, and then all of a sudden you don't put parentheses around it, and then you can get in trouble, okay? So it's going to be the arctan. Well, the arctan rule is 1 over 1 plus u squared, and then times, of course, the derivative of the inside, u prime, right? So we're going to go 1 over 1 plus, well, what's square root of x squared? That's just going to be x, right? Now I'll go ahead and, maybe, that's just going to be that, or x to the 1/2 squared. That's just going to be x. Okay, times the derivative of the inside. Derivative of that is 1/2 x to the negative 1/2. Okay? Right? So, clearly, I can simplify square root of x squared. I should do that. That's an x. Okay? Is there any other thing there that jumps out? So, what I like to do when we talk about the simplifying here, so when I do one of those, try to get the parentheses, the right spot, all that stuff, and then I like to just, when I have it written down, just step back and look at the whole thing. Okay? So, I've got this, and I've got this. They're together. They're a thing. They're a term. Nothing I can do with those. Right? Nothing I can do with that. Okay, so, and then I got this plus sign. And then I got this thing, and I got this quantity, but even this quantity is just one thing times some other things. So this is all times here. So the parentheses don't need to be there. So is there anything I can do with that? I need to put the x's together, right? If I have an x squared times an x cubed, that's x to the 5th. I need to do that. Well, right here, I got an x squared times an x to the negative 1/2. I need to add those powers together and put those together. Okay, and then, of course, simplify that. So this part I need to do now. And probably, since I'm timesing, it would be good to put it together as just a fraction, right? The x squared, the x to the negative 1/2, add that, that's x to the 3/2. That should go on top. The bottom, I'll have a 2, and then I'll have this quantity here. Now, I'm not going to make you do that part. If you just want to do the x squared times that, get x to the 3/2, and do a times, and then a 1/2. The 1/2 would really be better out in front here, to be honest with you. But it wouldn't have to be. And then if you just want to go 1 over 1 plus x, right? That's okay. I mean, that's okay. You could leave that, right? Now, another alternative would be x to the 3/2 on top, and then 2 times 1 plus x on the bottom, right? That would be another alternative. I think I got everything there, right? Okay, so like this, but you could leave it like that. And then, of course, you got your 2x arctan x to the 1/2 here, right? So that would be okay. But sometimes, many times, you get here and you're just done, right? But just kind of step back, look at the whole thing as a total, and see if there's something that can be put together. Again, this going down to this step is just kind of rearranging, moving things around, but not really doing much. to it, so I don't care as much about that. Okay, what else? What else? Okay, let me talk about 21 then. 21 says y equals, or f of x equals arcsecant of x over 2. Now, normally I would write that 1/2 x, but I'm not going to this time, and you'll see why in a second. So you look and you say, well, we don't have a rule for arcsecant. Why didn't we put rules for those on there? Well, here's why. If you do y equals cosine of x, again, it goes back to this input-output, interchanging the input and output thing. Then what is the reciprocal of cosine? Secant, right? So cosine x is equal to 1 over secant x, right? Would you agree with that? Or secant x is equal to 1 over cosine x. They're reciprocals. But now, remember when we were doing the inverse thing on Friday, we were talking about how cosine, you put angles in and you get values out, right? So cosine gets values that are between -1 and 1, and secant gets values that are between 1 and infinity and -1 and infinity. Remember that? You guys remember what the secant graph looks like? Secant graph is you take your cosine graph and you do this, and then you put asymptotes everywhere cosine is 0, because if cosine is 0, this is undefined, right? And you get this, and then you have the graph that goes up like that. Remember that? Like that. Then you have, well, I did that. I missed an asymptote in there. But anyway, you get the point, right? That's what the secant graph looks like. Okay? Now, so their outputs are reciprocals. So when we talk about cosine and secant are reciprocals, their outputs are reciprocals. So what's the relationship with arc cosine and arc secant? What are reciprocals? Their inputs are reciprocals, right? Because arc cosine, you interchange the x and the y. So if you have a y equals arc secant x, so you need a different rule, a derivative rule for secant and cosine, and that's what we have on our notes there. We have separate rules. But arc secant is the same as arc cosine what? That's all you do. So if you ever had an arc secant, an arc cotangent, or an arc cosecant, if you had any of the co-functions, we call them, okay? If you had any, or not the co-functions, but the reciprocal functions, so secant, cotangent, or cosecant, you have any of those, then all you do is take whatever the input is and just flip it, and then you got the other one. So that's how I would do this one. So I would write this as arc cosine 2x to the -1. Now do my arc cosine rule. So y prime would be -1 over the square root 1 minus hello? Yeah. Okay. I'll tell him. Yep. At 8:35, Harish, you have to go to the office. Okay. All right. So we have that. So -1 over the square root of 1 minus 2x to the -1 quantity squared times the derivative inside, -2x to the -2. Okay? And now, what can we do with that? Mostly, it would be rearranging. I'm gonna say, I mean, the safe bet to me would be to go ahead and square this. I mean, I just think we should, but sometimes that gets messy in there. So, for the most part, with the arc sine and the arc cosines, where we have this u squared, the last problem we just did, if it's a single term, then yeah, we should square it. But if it's like a 1 plus x quantity squared, don't mess with it. Don't foil it. you know, I'm not going to worry too much about that. Okay. Now, if you're not sure, you get on there and you say, yeah, I'm gonna I can simplify that. You want to go ahead, that's fine. But one like this, we probably should. I mean, that's just 4x. Remember, power to power, we just multiply. The negative times the negative, for sure we should. So this, to me, this would be on top. The 2 would be on top up here. Okay, this is x to the negative 2. I could put it on top. That's fine. I can leave it x to the negative 2 on top. Or I could move it to the bottom as x squared. That's fine. Okay, and then we got 1 minus, and then this would be 4x to the negative 2, something like that. And then just, right, just leave it like that. Good enough. Okay, so once we write it like this, then yes, we need to be able to do this, right? I'm not going to give it to you like that. But once we write it like this, then yes, we should be able to do that. Okay, let's talk a little bit about 37 through 39. So we have this graph. So this is what we were talking about last time with the domain issues. If you go this direction, this is what we were doing when we did our derivative. We didn't have to worry about our domain issues going this other way. Okay, because the number you put into arcsine has to be from -1 to 1, right? So you would never have a 5 in here, right? We would have numbers like 1/2. Okay, well, what's arcsine of 1/2? The angle, remember Coach Harris would say, the angle whose sine is 1/2. What is that? Pi 6. And then you get sine of pi 6, which is 1/2. We're always going to get that number back, right? Whatever we have inside of arcsine is going to be a number from -1 to 1, okay? And when we do the arcsine of it, we're always going to get some number from negative pi halves to pi halves, either the first or fourth quadrant, okay? If this would have been a -1/2, we'd got a negative pi 6 here. And then the sine of negative pi 6 would be -1/2. We're always going to get that back, okay? But when we go the other direction, like this, then we run into trouble. Because now I'm going to use, 5's a hard one because that's not one of our normal values we think of. Now, I think everybody, when you go around the unit circle, needs to know these values. This is pi halves, this is pi, and this is 3 pi halves. I think everybody should know these values right here, right? I mean, those just basic values, you know, pi is 3.4, 2 pi 6.28. That's probably the one we know the least. That's 3 pi halves. Okay, so if I do sine of 5, where is 5? Well, 5's like right there. That's where 5 would be. Okay, so sine of 5 would be down here. All right. Well, if you do, but let's do one that we know. Let's take the 5 out. Let's do one in the fourth quadrant we know. So let's do sine of. That's pretty close to 5 pi thirds. Okay. Now. So the question is, would we get out 5 pi thirds here? That's the question, right? Well, what is sine of 5 pi thirds? What are the coordinates down here of 5 pi thirds? Isn't this 1/2? -√3/2. Okay, and so the sine is the y value, right? So the sine of 5 pi thirds is -√3/2. Okay, and now we want to do the arcsine of that. What's the arcsine of -√3/2? Remember, out of arcsine, we always get values from negative pi halves to pi halves. So we're not going to get 5 pi thirds. We're going to get what? Negative pi thirds. We're going to go this way to get to that point, right? So we're going to get out negative pi thirds out of this. We're not going to get 5 pi thirds. We're always going to get something between negative pi halves and pi halves. So that's why that graph bounces back and forth from negative pi halves to pi halves. Okay? What if you had one in the third quadrant? What if it was 4 pi thirds? Let's put 4 pi thirds in there. Do you get out 4 pi thirds? No. What's this point over here? This point is -1/2, -√3/2, right? So sine of 4 pi thirds is still -√3/2. What's the arcsine of -√3/2? Negative pi thirds. That's because we don't need to worry about this quadrant because this has, the ones over here have the same sine, have the same y values as the ones over here. And the ones in this quadrant have the same y values as the ones over here. So we don't, see, so you're always going to get ones between negative pi half and pi half. Okay? So that's why arc sine of 5 is not going to equal 5 because of those domain issues. And so then 38 is the same thing. For what values of x does it hold? Well, when x is between negative pi halves and pi halves. Okay, and then finally, but here's where the calculus part comes in. Okay, explain, so what's the derivative? So if f is equal to the arc sine of the sine of x, right? You know, if it was going to work, if there weren't any domain issues, right? If there weren't any domain issues, then this should equal x, right? Don't write that yet, but this should equal x. And so what should the derivative be? Should be 1, right? Should be 1. But we know it's not going to be, right? We know it's not going to be because of what we just talked about. So let's just do our derivative rule. So we start on the outside. So what's the derivative of arc sine? It's 1 over the square root of 1 minus u squared, right? So u squared is sine, that'd be sine squared, times the derivative of the inside. Derivative of sine is cosine. Now, what's 1 minus sine squared? That's just cosine squared. So this is now 1 over the square root of cosine squared times cosine. Now, I know what you're thinking. What's the square root of cosine squared? Well, you do have that answer in the book, but you would think, well, that's cosine. And then cosine divided by cosine would be 1. But we just said it wasn't. Well, remember, we did this the other day. What's the square root of x squared? We did this on Friday. It's this, right? Because what if you do the square root of negative 3 squared? So that's why I went through all that stuff last time. What if you do the square root of negative 3 squared? What do you get? You get 3, right? Because negative 3 squared is 9. You do the square root of 9, that's 3. Not plus or minus. We're not solving an equation. The square root of 9 is 3. So you have to put the absolute value bars around it. So you don't get negative 3, but if you put bars around it, you do. Right? Then you get the right answer. So you have to put bars around it. So the same thing's true here. So we get cosine on top, and we get absolute value cosine on the bottom. Now, look at that graph. Okay, when cosine is positive, what does this divide out to? When cosine's positive, what's that divide out to? 1. When cosine's, yeah, go, yeah, yes. When cosine is positive, it divides out to 1. When cosine is negative, it divides out to negative 1, right? Because the top would be negative, but the bottom will still be positive, right? So you'd have like 3 over 3, that'd be 1, or it could be negative 3 over 3, that'd be negative 1. Well, look at that graph. What are the slopes? 1, negative 1, negative 1, 1, negative 1, right? Which is what the derivative tells us it would be. Okay, this is really plus or minus 1. And it's undefined. We have a sharp point when? We have a sharp point whenever cosine is 0. At pi halves, at 3 pi halves, at negative pi halves. Whenever cosine is 0, that graph has a sharp point. This derivative would be undefined. Because you'd have 0 divided by 0. All right. So that's just some good stuff with domains and the inverse trig function stuff. Important things, but a little bit of derivative practice there too. All right, let's turn to 195. Let's focus in on the derivative exam. Any practice ones you've done now that you want to ask about? should have this next
Hmm?
53. Okay. So on 53, again, one of the things I've said is how you write these things is a lot of times key to how successful you are in doing the derivative. And on this one, it's critically important you do that first. Okay? When you see the sign squared, it's the whole thing squared. That's critical. Okay? So we've got to do that. So to do this derivative, we've got to start on the outside. And so that would be what rule? Not that you have to say this to yourself, but what rule are we starting with? Power rule, the x squared, right? We're starting with the outer function, which is a square. So we're going to bring the 2 down in front. We're going to leave the inside alone. Make sure I got enough parentheses here. To the first, which doesn't really matter, times, now the derivative of the inside is going to be a real mess here, right? Now we're in the chain rule. We're in step 3, derivative of the outside. Step 1, leave the inside alone. Step 2, now step 3, do the derivative of the inside. Now it looks like it's going to be a real mess, so one great big set of parentheses would be pretty key here. And I can also see there's going to be a product rule at some point in there, which means there's going to be a plus because I'm looking at that x times cosine, so at some point I'm going to do a product rule. But not yet, right? Because all I'm looking at now is the red thing, right? That's all I'm looking at now. So I've got step 1 at 8:35. Huh. I think so. Uh-huh. That might have been 8:36 because he was waiting for permission. All right. So now I'm looking at the red thing, right? That's all I care about. And I've got my parentheses there, so I know it's got to go in there. So everything I'm about to do has got to go inside those parentheses. Okay? So what do I start with now? What am I doing the derivative of? Sum, right? I'm doing the out. So now I start with the outside again. Yeah, there's a product rule. I don't care about that yet. I'm not there yet. Derivative sine is cosine. Leave step 1, derivative the outside, cosine. Step 2, leave the inside alone, which is that. Step 3, times the derivative of the inside. But now this all has to stay inside those big parentheses. That's really important. I mean, as it turns out, it may not have been if I put it outside, but oftentimes it could be. Okay, so right now I'm ready to do step 3, the derivative of the inside. And that means this. So, well, whoops. So that means this. So all I really care about right now is that right there. Okay? And so I need a big set of parentheses for that, but that big set of parentheses has to stay inside my other set of parentheses. Okay? As it turns out here, it's not really going to matter because everything's multiplied, but normally it might. But these black parentheses aren't really going to matter because now I'm ready to do step 3, the inside, and now that's a product rule. So the derivative of x is 1. Cosine left alone, plus x left alone. Derivative of cosine is a minus, so I'm gonna switch that plus to a minus. Minus, so derivative of x, or x is gonna be left alone, and then derivative of cosine is negative, so then that'd be sine. Barely got that in there. Now, as I step back to look at this, I'm looking, especially where there's plus signs, because I like to group things into terms, right? And things that are multiplied. That's one thing right there. So we got to be careful. We understand that's not a multiplication right there. So that's one thing. This is all one thing, but it's all multiplied. So really, that's one thing. And then this is one thing. And to me, those are 4 factors or 4 things that I could move around. And since I don't have any plus signs between any of the green stuff, I could just rearrange. But to be honest, there's no need to rearrange anything. I mean, there's nothing I can put together. I can't put this with that, nothing. So it's just, that's pretty much it. Pretty much done. Okay? All right? What else? Good one. 39. equals log base 2 of, now again, how you write it is key. To me, I see cube root. I'm going to put that all to the 1/3 power. That's all inside the log. Now, I could put that power on in that, right? I mean, when you have, this would be totally up to you. And it'll look very different depending how you do it. But when you have AB squared, what's AB squared? A squared B squared. And if you have A squared B squared to the 3rd, that's A6 B6, right? I mean, you power on a power, you multiply, and if it's a product in there, you can put the power. It's not distributing, but it feels kind of like distributing, but right? We normally say we don't distribute powers. I mean, that's what I usually say. X, if I got x plus 4 squared, I cannot distribute that squared, right? We cannot do that. Okay. But on something like this, we can, and power you multiply. So here we could make this in here log base 2, and then this would be x to the 1/3 e to the 1/3 x. You know, and now you're going to have a product rule there. Here, when you go to do your inside, you're going to have a chain rule. You're going to bring the 1/3 down front. You're going to drop it, and then you're going to tack on, you know, the derivative inside, which is a product rule. So what do you want? I mean, what do you vote for? Vote for 1 or 2? How many say 2? Okay. Now, how many would you guys have thought to do that, though? You know, if you wouldn't have thought of it, then maybe we should do 1, right? If you wouldn't have thought to do that, then maybe we should do 1, okay? But they'll just look different when you get done. But again, when I grade them, I'll just follow your steps. And just say, was that a good step? Was that a good step? Was that a good step? Did he simplify again? What do you got? Okay? And that's where you can type in your calculator and see if they're equal. Okay, well, let's just go through 1. So let's say you didn't think of that. You didn't simplify it first. You just went, okay? So first we start with our log rule. So our log rule is 1 over whatever's on the inside, 1 over u. So that's x e to the x to the 1/3 times 1 over ln2, right? I mean, I'm just following my log rule here. Log base b, 1 over u times 1 over lnb, so 1 over ln2, now times u prime. So that's where all the work is on this one, is now times the derivative of the inside, right? So I put a big set of parentheses because that's what comes next. So it's just 1 over the inside, 1 over ln2, and now I got to do the whole thing. Okay? So that's not bad. So now I'm just looking at the blue part. So I'm going to bring the 1/3 down front. I'm going to leave x e to the x to the negative 2/3, right? Times the derivative of its inside. So big set of parentheses. And now all I'm looking at is the inside. Okay? Of that. So the inside of that is product rule. So derivative of 1, or derivative of x is 1, e to the x left alone. Plus x left alone, derivative of e to the x, e to the x. That really wasn't that bad. Okay? Alright, so now if I was going to rearrange anything, I've got this is one thing, I've got this is one thing, I'm timesing by 2 other things. So as long as I keep each of those green pieces together, you know, I mean that, I mean the 1/3, I guess you could say there's 2 things here. You could say that's that one, that's one thing, and that's one thing, right? Because if I had another, did they find you?
Yeah.
Did you get your picture taken?
Yeah.
Student of the month? Or the week?
Yeah. Not good picture.
Congratulations. Alright. Who was going to vote? Oh no, that was the other thing. I made a deal with somebody. I'd vote for them for student of the week if they voted for me. Cody. Yeah, it was Cody. Yeah, it was Cody. That's what I'm looking at Braylon, because that's where Cody sits. I'm like, it was Braylon or it was Cody? I don't know. You wouldn't vote for me, would you? Thanks a lot. Alright. So anyway, 1/3. So like if you had a 1/2 over here and a 1/3, you should multiply those together, you know, something like that. But, okay. But otherwise, it really, I mean, I can't even see. I mean, well, do see one that I should put together. Now, would I count this? So grading the gateway now. So I usually say, if it's wrong, it's wrong, and there's what I consider obvious and fine you need to do. Okay, but there is some leeway on your part, right? You can miss 2 and still pass it. And when you're on the 4th or 5th one, you might get away with some things that you might not have on the first one, right? Because you're going to get 30 out of 30 in the grade book. You can miss 2 and get 30 out of 30 in the grade book. So in my mind, you need to earn that one, right? I mean, you need to have 8 solid, right? Good ones to get 30 out of 30. And so this might be one of those where I might count this wrong in the first one, but I might not after that. Maybe that's fair, maybe that's not fair. But now that I look at it, this and this, right? It's kind of like just having 2 things, bases are the same, just add or subtract the powers. Because I can flip this now, since each one of these things is a product, I can just take that and flip that down. Well, that's going to be x e to the x to the 2/3 on the bottom, and then there's going to be an x e to the x to the 1/3. What does that go together as? Just a power of 1, right? X e to the x on the bottom. So that would actually simplify pretty nicely. So at that point, all you really have left, so everything would be on the bottom except this set of parentheses here. So e to the x plus x e to the x, and then the bottom would have an x e to the x to the first, right? And it would have an ln2, and it would have this 3 from the 1/3. So that'd be on the bottom, that'd be on the bottom. Both of those things would be on the bottom. This thing would be on the top. And that simplifies really pretty nicely. So, that's one of those. If you got something that you can put together, by adding powers together and stuff, you probably should. Okay. One more? I've got some kind of a maze or a puzzle here or something. Some practice those. Okay. One more though. What about 24? What's the answer to 24? 0. 0. I wouldn't give you, well, it'd be nice if I did. I suppose just give you one like that. But it might be in one, right? It might be like, it might be part of one. Like x squared plus pi cubed or, something like that. All right. So here's some space to do work. So your assignment is basically this little maze activity, and then page 195, or get on the websites to practice. Okay? Now, so the way this is supposed to work, is you start with A. Now it says find the slope of the tangent at the indicated point. So in other words, now again, what we don't have in here is any implicit differentiation. So I'll throw some of those up at you tomorrow that we'll practice. But it wouldn't hurt to get on the IXL. What I say it was, M1. And that'd be a good place to go tonight and do a few too, is M1 on the IXL. If you're going to do any IXL at all, I do M1, because that's implicit. And that's definitely on the quiz, okay, on the gateway. So this worksheet doesn't have that. Page 195 doesn't have it. Okay, so start with A. So you go ahead and do your derivative in the work, but then you got to plug. So to see where you go next in the maze, you have to plug in and find the slope, right, of the tangent line, which of course is what derivative is, the slope of the tangent line. So you work out your derivative, plug in a 3, get your slope, and then that's the direction you go. And then you just draw through the boxes and you follow the maze till you get to the end. Okay? I think you have to do most of it. You end up doing most of it by the time you get done. Well, I think there might be 2 you end up not doing, which for practice would not be bad to do anyway. All right, so anyway, that's just a little extra practice. So that and page 195.